Okay, so I'm just going to cover radioactivity and toxicity in rocks. So, if you're wondering why rocks are important and why I should have to learn about rocks and minerals, well, they could very easily kill you. So, you should know what they are. Okay, so the thing that for both one radioactivity and two toxicity, the most important thing is to actually know what you've got. And I'll explain why that's important in both this first bit and the second bit, toxicity. So for the first one, radioactivity, I've got a Geiger counter here. I know most of you won't have easy access to a Geiger counter, so I've done it for you. And so the Geiger counter doesn't, the alpha radiation is not too dangerous unless you eat it. So one of the big things to get out of this is to always wash your hands when dealing with rocks, but actually just to always wash your hands whenever you eat food for COVID or whatever. Just always wash your hands, okay? So that's the big thing really to get out of this is to wash your hands. All right, that's the safest thing to do. So I've got this one going for 5 minutes. Now I first did the background count, and that's at the bottom. And at the top, I took the largest, blackest rock I could get, and I'll tell you why in a second. But what's considered safe is just the background radiation that comes from the ground that you stand on, and there's rocks underneath you. And so that's like 50 to 60 counts per minute. And you'll see at the end, I only get to about 90 after 5 minutes. So that's like about 20 per minute. So it's fairly low. And I've went around different other places too, and 20 seems to be about standard no matter where I go. And then if it's over 100 in the minute, now I get to 130 after 5 minutes, and that's with the black rock. So right up against the black rock, it's still within normal limits, and it would have to be over 500 for you to investigate that as dangerous. But it's still 50% higher than background radiation. So I say keep your rocks in the garage or in the shed or something. And also keep it well ventilated, because some of the products, the dusts and the radioactive gases like argon from granite, they just keep it ventilated. Some air can easily come in and out, and you'll be safe. And so that's the moral of the story. Now, why did I get the dark rocks? Okay, because both of these tables are from Wikipedia. So the radioactive elements are here. Now, you're probably most aware of uranium. Americanum, I think it is but it only gives off alpha radiation, so that's not strong enough to be picked up as a count, and it's not that dangerous. You're mainly just picking up gamma and beta and gamma radiation in the counts. That one there is in the smoke detector, so I couldn't get anything from that. I'm not going to try the cell phone like my students wanted me to, because that's electromagnetic radiation. It's just too embarrassing. Okay, sorry. I'm not going to test for that, even though that's a conspiracy theory. So thorium, uranium are the ones, and you can see that they're heavy. And so they're not going to they're going to sink and not easily. From silicon dioxide and our previous discussion on elements, that the lighter elements float to the top, and the lighter elements are the ones that solidify, and so that's what we see. So if you're going to try and get these heavier radioactive elements, you're going to have to go to what they call mafic rocks, which are sort of like the iron and the magnesium and the heavier elements, rather than the felsic rocks, which is like the potassium feldspar. So I'm going to pick the most mafic rocks I can get, the ones from deep within the crust full of heavy elements. Sort of anything that's dark. And the darkest thing I've got is this basalt. That's also the biggest thing I've got. And it did give me a 50% increase in radiation, although it's perfectly within safe limits. Nonetheless, it's going out of my room. Okay, and so that's why I chose the dark elements, because the dark ones are the heavier elements usually. So I just wanted to keep this first bit to the 5 minutes, because I didn't want to sort of do it fast forward. I wanted you to see how quickly the counts go. You could just be unlucky and get hit by one gamma ray, and that causes cancer that you die from. within a few months, but the probability of that is going to be pretty low. Okay, just to reiterate what I said the first time, the most important thing is to wash your hands. So, it doesn't even matter. The problem with rocks is it doesn't matter, even if you think you know what you have. Rocks are mixtures of minerals and there could be trace elements of something that's dangerous. So the best thing you can do, of course, is know what you have so you don't have anything that's a major concentration issue. And check your MSDSs. So you avoid cutting or breaking the rocks because that creates dust and releases vapors. So cinnabar, which is something I've seen even on the street where kids can grab, if you snap that, the mercury vapor can cause a miscarriage just from snapping a small amount of rock, just a small piece. And you never really know. And if you think you've got a safe rock, you don't know. So you should always wash your hands and avoid dust as much as possible. And so even if I've got two samples here. So you need to check your MSDSs. So the stibnite here is extremely dangerous. It's got because it's got all that dust. It's because it gives off a lot of dust. It's category 2 carcinogen. You're going to see this is not that relevant in a second, but it does produce a lot of the dust, so that makes it highly dangerous. All right, so pretty much with all of these, they should be locked up and in a container that's sealed. But just to emphasize, so the other one is pyrite that I have. Now, this one is considered not dangerous. This is how difficult it is to interpret these safety data sheets, but it can actually contain arsenic. All right, so it's hard to know what's dangerous, what's not. If I go to Wikipedia again, it's done sort of a heat map on like 10 critical criteria, and the only thing everyone agrees on is mercury, lead, and bismuth, I think it is just dangerous and just stay away from it as much as you can. And these other ones are more or less so dangerous depending on what's going on. Now, to illustrate that point, what's the safest thing you can possibly play around with? The really common stuff is like quartz, and people hang that around their neck. So why has it got all this danger here? It's because that's to do with cutting it. So if someone's cutting these stones all day and the dust is getting into their lungs, they'll get silicosis and die by their 40s or 50s or whatever. And same with feldspars. It's about cutting it. The solid rock is like completely safe and you're never going to get away from it anyway. You're walking all over it in the beach and you're probably breathing it in with the sand, and it's just everywhere. So it's about cutting it. So just be a little bit aware that these cancer ones, you've got to interpret what these MSDSs are about. Now, this one, unfortunately, galena, is really common in schools, and yuck, that one just screams danger all over it. And if you look at what it is, it's lead. It's one of those scary heat map ones. So the lead, mercury, and bismuth. So watch out for those, yeah? Do your very best to know exactly which rocks and minerals you have. Always check the MSDSs. Try and interpret that into what that means. Keep the super dangerous ones sealed. And always wash your hands whenever you've finished looking at them and analysing them or whatever.